Okay guys, now the second part of this lesson, which is stage number 4, dynamics and application of Newton's laws. I'm going to tell you about two applications only, okay, and those are the only two applications in which you're going to be tested for this stage. So the first one is this. The problem says find the acceleration of a particle of 5 kilograms which lays on the floor and is being subjected to three forces, and I'm giving you all the forces with all their magnitudes and their angles. And it says use a dynamical analysis. So let's do this problem. Okay, so a dynamical analysis is performed in the following way. What you do first is this. You draw a Cartesian plane like we always do, and you place your particle in the middle. Okay, next you're gonna draw all the forces acting on this particle. First we have this F1, which is 5 newtons at 0 degrees. It's right here. This is F1. And then F2 of 4 newtons at 180 degrees. I'm gonna do it in another color. This is F2, and it goes in this direction. And finally F3 of 7 newtons at 60 degrees, which is more or less over here, more or less. Okay, so these are the three forces acting on your particle. And when you add all of these forces, they're gonna produce a resultant force. Okay, because basically all these three forces are pulling the particle in their respective directions. Okay, and when you add them all, which because you can do that, right? They are vectors. You can add vectors. You're gonna produce as a result a resultant force or resulting force. Okay, and we want to get that resulting force. Once we get that resulting force, the rest of the problem is extremely simple. Okay, so that is the difficult part, finding that resulting force. We want to find how much is that resulting force, the addition of these three forces. Okay, how do we do that? I already told you. Okay, because why do I say that I already told you how to perform this? Because these three things are vectors, guys. F1, F2, and F3 are vectors, and all that you're doing is adding three vectors to produce the resulting vector. Okay, so if you remember well, that process was carried out in the following way with the process of the table, right? You're gonna write this F1, F2, F3, and Fr. And you're gonna draw the table for their components, the components of each of these. The X component goes here and the Y component goes here. Okay, so now all we have to do is get the components of F1, F1X, F1Y, and then F2, F2X goes here, F2Y, F3X, F3Y, and then we add all of these three and we get the X component of the resulting force, and we add all these three and we get the Y components of the resulting force. Okay, so I'm gonna do, I have my calculator by my side, and that's all we have to do first. Okay, I want you to do that with me. I want you to get the components of each of these forces and remember the formulas. For f of x, for the x component, that's the magnitude times the cosine of the angle of the force, and for the y component you multiply the magnitude times the sine of the respective angle. Okay, so I'm gonna speak out loud how to do it in this one. F1x is gonna be I'm sorry, it's gonna be 5 newtons times the cosine of 0, and that's gonna be 5. And F1y will be the magnitude, which is 5 newtons, times the sine of this 0. And in the end, you will get 0. Okay, and then do the rest of them. Okay, I'm gonna do that myself. and these are the values that I got. Okay, all of these. I give you some time to complete them, please. And now you just add column by column all these numbers. Okay, all of these three numbers, you add them with the respective signs and all. And you will get these two values. Okay, so those are the components of the resulting force. And once we know the components, Frx, which is equal to 4.5 newtons, and Fr, which is newtons, now we can find the resulting force, right? Because we have the components of of this resultant force, and basically we can get its magnitude by means of the Pythagorean theorem, like we know, right? By performing this expression. Okay, so let's input the components here. That will be 4.5 newtons to the square plus 6.06 newtons to the square. And so the resultant force is, one more time, let's calculate that expression in the calculator. It's rather easy. I'm getting 7.54 newtons. And so this is my resulting force. And I told you, once we get this value, the rest is very easy. This is the difficult part, so to speak. Okay, what do I do with the resulting force? This is not my final answer because I'm not being asked what is the resulting force. Okay, I'm being asked find the acceleration of a particle of 5 kilograms, which is being acted upon by these three forces. Okay, once you have the resulting force, getting this acceleration is very easy. All you have to do is this. Okay, first I'm gonna erase everything. Okay, I don't need any of this anymore. I don't care. All of this process in the end is so that you get this value. Once you have this value, you can erase everything. So let's memorize this value, 7.54. Let's write it here, newtons. And now let's find acceleration. In order to find the acceleration of the particle, all we have to do is help ourselves with the second law of motion of Newton, which says this, that force equals mass times acceleration. Do you remember this one? Okay, so we have the force acting on the particle, the resulting force. The sum of these three forces in the end is this. So that's the force that I'm gonna input in here. So I'm gonna get 7.54 newtons. We have the mass of the particle, which is 5 kilograms. And so now you can see that we can get the acceleration by simply isolating this equation. We're gonna have this, and so that value will be 1.5 meters per second squared. And this is the final result of this problem. This is the acceleration that you were being asked. Okay, and that's how you do it. So what you do first is you get the resulting force of all the forces acting on the particle. That's the first thing you do. Get the resultant force. How? Like in the same way we've been doing these things. Forces are vectors, so all you know about vectors you can apply to forces. Okay, if you know how to perform vector addition by the component method, and that means by the little table and so on, then you can perform addition of forces because forces are vectors. It's that simple, guys. And then you perform this little other process, and you get the final result. Okay, let's go to the other problem. I'm only gonna teach you two problems. This is the next. This is about tensions. Okay, so it says a piñata of 2 kilograms hangs from two ropes, like shown in the image. What image? The one I'm gonna draw in a moment. Find the tension on both ropes using dynamical analysis. So again, we have to perform something very similar, very similar to what we did in the first problem. So first let me give you the drawing, okay, or the image. You have the ceiling, and then you have a piñata hanging like so. This is the piñata. Remember, just draw little objects, okay, little points and or stuff like that. Don't draw the whole piñata. It doesn't make any sense. Okay, and the angles are this. Let's suppose that this is an angle of 60 degrees and this is an angle of 20 degrees. Okay, so this is the image. Fine. Okay, what do we do next? We perform the dynamical analysis like we did before. So okay, I'm gonna draw a Cartesian plane, and in this case, I'm gonna draw it over the diagram. I'm gonna draw it in here, like so. Okay, and I'm gonna draw all the forces acting on my particle. This is my particle. How many forces are acting on it? Let's see. Let's see. First, its weight. Okay, you have its own weight pulling it downwards, pulling the particle downwards. And then you have the forces that are applied by the two ropes, right? This is one of the forces, and this is the other force. Okay, and I'm gonna call these forces T1, tension 1, and T2, tension number 2. That's how we often call forces that are being applied by ropes. We call them tensions, okay? So when I ask you find the tension, all I'm asking you is find the force that a rope applies, okay? It's called tension. That's for, I don't know, traditionally they've been called that way. Okay, so we have these three forces, T1, T2, and the weight. And we want to perform a dynamical analysis. So one more time, what do we do? What we do first is get the angles and the angles of all of all these forces. Okay, let's get the angles. You're gonna see why in a moment. So the angle of T1. What is the angle? It's this one. Okay, remember it's always measured with respect to the x-axis. The angle of this force is measured. It's this one. This is the angle of T1, and it's gonna be the same as this angle, as this angle of 20 degrees, because of properties of the lines. When you have two parallel lines and one line crosses them in this way, this angle is the same as this angle. Okay, this is one of the most um, important theorems in mathematics, right? I believe you must remember this one. And so this angle is the same as this, and since we know this angle, then we know this angle. So the angle of T1 is 20 degrees. Okay, now what is the angle of T2? I'm gonna draw it in pink. Okay, first I'm gonna erase this because I want everything with clarity. And now in pink, I'm gonna draw the angle of T2. The angle of T2, it's not this, guys. Okay, this is not the angle of T2, because remember that always the angle of a vector is always measured with respect to the positive x-axis. So I need to start here. This is the angle of T2, all of this. So how do I get it? How do I find it? Well, using this other angle, okay? Using this other angle. I'll do it in blue. If I know this angle, then I can calculate the pink angle, because the pink angle is simply 180 minus the blue angle. And how much is the blue angle? The blue angle is 60, for the same reason that I told you before. This angle is the same as this angle, and so if this is 60, this is 60. And now that I know that this is 60, therefore the angle of T2 will be 120. You see, so this is just simple geometry. This is 120 degrees, and I can now put it over here. The angle of T2 is 120 degrees. And the angle of the weight is very simple. It's 270 degrees because it's going downwards. Okay. Okay. So now we have the angles of all the forces. Okay. We don't have the magnitudes of T1 and T2, because obviously that's what we're trying to find. And the magnitude of the weight, we also have it. The magnitude of the weight, because we have the mass of the object. And remember that the weight is equal to mass times gravity. So the weight will be 2 kilograms times 9.8. Perform that multiplication, please. 2 times 9.8, and you will get 19.6 newtons. Okay, so this is the magnitude of the weight. This is the angle of the weight. This is the angle of the tension 2 and the angle of the tension 1. But we don't know yet T1 nor T2, because in fact this is the quantities that we're trying to get. Okay, what's next? What's coming next? The same thing. The thing about the table. We need to add these three forces, and so what you need to do is this. We're gonna draw the table: T1, T2, weight, and the resulting force. Okay, like that. So same table. Here goes the x component, here goes the y component. Okay, first get the x component and the y component of the weight, because that's the easiest thing. So let's get them, please. You should get this value, 0 and minus 19.6. Okay, now T1x. T1x. In theory, you should have T1, like the magnitude, in order to calculate T1x, okay? Because T1x is going to be the magnitude of T1 times the cosine of its angle. But you don't have the magnitude of T1. So what do? What you do is you just express it. You just express how much it would be T1x. T1x is going to be T1 cosine of 20. You see? I still cannot calculate all of this because I do not have T1. So this is the most that we can do. T1 cosine of 20, and the same is going to be for W. The y component. I'm sorry, I said W. I don't know why I said that. The y component is going to be T1 sine. The same for T2. T2x will be T2, whatever T2 is, times the cosine of its angle, which is 120, and T2y will be T2 times the sine of its angle. Okay, so we have all of this. All right, now what do we do next? We're gonna add all of these numbers, this, and this, and we're gonna get FRX. Of course, it's not gonna be fitting here, so I'm gonna do it in another over here. I'm gonna say FRX is equal to T1 cosine of 20 plus T2 cosine of 120 plus 0, so I don't add anymore, and FRY is equal to T1 sine of 20 plus T2 sine of 120 minus 19.6. Okay, and we have these components. Okay, now how do we get the resulting force? or what's to be done next. Okay, you have to pay attention to what I'm gonna say to you. This is the whole crux of this problem. The whole idea behind this problem is realizing. You have to realize, you have to notice, you have to understand something very important. For this particular piñata that is in here, the resultant forces applied on this piñata are zero, guys. The resultant force is zero. Okay? Why do I say that? Because it's not moving, it's static, it's just hanging. Okay? When you hang a piñata from the ceiling, and if there is no wind or anything like that, it's just gonna remain there, static. And that means that all the forces acting upon it sum zero. The sum of all those forces is zero. Therefore, the resultant force is zero, and therefore, this value and this value have to be zero. These two things have to be zero, okay? So I'm gonna make that substitution. This and this will be zero. Zero and zero. Okay, and we're almost done, more or less. Okay, now we have this. Look at this. We have two equations that go like this: 0 equals t1 cosine of 20 plus t2 cosine of 120. Okay, and then we have 0 equals t1 sine of 20 plus t2 sine of 120 minus 19.6. So let's calculate the cosine of 20 and the sine of 20 and the cosine of 120 and the sine of 120. Okay, let's simplify these equations in by doing that. So 0 equals, let's calculate those trigonometric functions. Okay, so let's do it. So you're gonna get this. So please make sure to do it by yourself. Okay, this is what I got. Okay, by with the simplification of the trigonometric functions, I get these values. Okay, and once we get to this point, we can again one more time we can discard everything that we have done up to this point. We can get done with it. We don't care about this anymore. None of this, none of this. All I wanted in the end is this system of two equations. Okay, that's all I wanted. So I can erase everything. And now all that remains to be done is solving the system of two equations. Okay, I'm gonna write them down in here one more time. 0.93 times t1 minus 0.5 times t2 equals 0, and 0.34 t1 plus 0.86 t2 minus 19.6 equals 0. So once you solve these two equations, remember you have two equations with two variables, t1 and t2. Can you see? And you can solve this system by substitution or elimination and so on. But I don't want you to do that. Okay, I'm not gonna ask you to do that by hand, because it's actually quite long. Okay, and you can make mistakes very frequently or very easily. So what I'm gonna teach you in a moment, I'm gonna stop the video right now, and I'm gonna teach you how to do this in the computer. Okay, as you may know, as you probably know, there are already web applications on the internet in which you can input the values of the coefficients, and the application or the software solves this equation for you. It's going to tell you what the value of T1 is, and it's going to tell you what the value of T2 is, and you're done. So basically the computer is doing the work for you. You don't have to do this by hand. Okay, and that's how this works, guys. Okay, that's basically it. We solved two problems. That's enough for this dynamical analysis, because if I get more deep than that, we're not gonna finish the course. Okay, it's actually a lot of topics, a lot of complexity involved, and we cannot go deeper than this. We don't have the time. It's a very short time in which we have to solve at least the most basic examples, and that's it. Okay, so I'm gonna show you how to do this in the computer in order to get T1 and T2 in a moment. Okay, so thank you guys, and that's the end of the course. Basically, this is the last lesson. I hope you have made good use of this, and see you later. Bye.